How to accurately calculate transmission line sag and tension. Imagine a power line stretching across a valley, hanging between tall towers. How do engineers make sure that the wire stays safe, clear of the ground, and doesn't snap under its own weight? That's where calculating sag and tension comes into play. These calculations are key to keeping power flowing smoothly and safely. Let's start with the basics. Sag is the vertical dip of the wire at its midpoint between two supports. Tension is the pulling force along the wire, which keeps it from sagging too much or snapping. The span length is the horizontal distance between the two towers, and the weight per unit length includes the wire's own weight plus any extra loads like ice or wind. When the supports are at the same height, you can estimate the sag with a simple formula. The sag equals the weight per unit length times the span squared, divided by 8 times the horizontal tension. Think of it as a balance. Heavier wires or longer spans increase sag, while higher tension reduces it. For example, if the span is 50 meters, the wire weighs 20 kilograms per meter, and the tension is 10,000 newtons. You can plug those numbers into the formula to find the sag. Tension at the support is a bit more involved. It's higher than the horizontal tension because it also has to support the vertical load. You find it by combining the horizontal tension with half the weight times the span, using the Pythagorean theorem. This helps ensure the wire doesn't stretch too much or break. If the supports are at different heights, calculations get trickier. The wire no longer forms a simple parabola. It follows a catenary curve, which is more complex. Engineers use the catenary equations, involving hyperbolic functions, to model the shape accurately. These calculations often requiring iterative methods or specialized software, especially for long spans or heavy loads. Environmental factors also matter. Temperature changes cause the wire to expand or contract, affecting tension and sag. Wind pressure pushes the wire sideways, increasing tension and sag. Ice adds weight, making the wire sag more. Material properties like elasticity and thermal expansion influence how the wire reacts to these loads. In practice, engineers set the initial tension during installation to keep the sag within safe limits. They regularly check and adjust tension to account for environmental changes and aging wires. Proper calculations prevent wires from sagging too low or snapping, ensuring reliable power transmission. So, calculating sag and tension accurately involves understanding the physics of the wire, using simple formulas for basic cases, and applying more detailed catenary equations for complex situations. Considering environmental effects and material properties helps keep the power lines safe and efficient.